7. And this is x cubed y cubed minus y equals x. So this is a good time to be having your calculus toolbox if you don't remember what goes on here. This is the power rule here. So we take the derivative of this, using the power rule, minus the derivative of this, which is going to be dy dx, equals the derivative of this, which is 1. So we know what this is, we know what this is. We got to figure out what this is. So we're going to take x cubed times the derivative of y cubed, which is 3y squared, and then this is dy dx. Plus, now we take y cubed times the derivative of 3x, or x cubed, which is 3x squared, minus, and like I said, this becomes dy dx, and the derivative of x is 1. So this is how we're starting this. And then we still are going to get the dy dx is on one side, and the non-dy dx is on the other side. And we're going to combine my terms here, or not combine my terms, but we're going to multiply these factors out. So this is going to give us 3x cubed y squared dy dx plus 3x squared y cubed minus dy dx equals 1. And I'm going to put a red line under this to caution you on this when we start factoring out dy dx from these two. But I'm going to move this over here first by subtracting, and then we'll get to the cautionary note that we have for this right here. So I'm going to move that over. We get 3x cubed y squared dy dx minus dy dx equals 1 minus 3x squared y cubed. Now I'm going to factor this out. Again, this is a cautionary note because this is negative 1 times dy dx. So when I factor out dy dx out of here, you can easily see what this is, 3x cubed y squared, but this is a minus 1. So you've got to be careful on that. Equals 1 minus 3x squared y cubed. Divide both sides by the number multiplying by dy dx. Dy dx then becomes 1 minus 3x squared y cubed over this monster here, 3x cubed y squared minus 1. Nothing can cancel out because these are not multiplying. So that is pretty much what we call prime. No factors in common. All right? Let's jump to number 11. This now involves a little trigonometry. Can't get enough of that trigonometry. Sine of x plus 2 cosine 2y. Oh no. Looks like we've got a chain rule coming here. We're going to use the chain rule on this thing, and we're going to have just the derivative of sine x, which we know is cosine x. If you don't know, just make sure the calculus toolbox is warmed up, ready to go, all smoke coming off it. Plus, now, we're going to say that we're going to have cosine of u is y, and then we're going to say that u is 2y. So this is, we're taking this out, making that u, that makes this cosine y, and we're going to put the 2 in front because it's not going to have, this 2 is going to be in front because this is a number multiplying this. So we're just focusing on the chain rule here. Okay, so we know that cosine of the derivative of the cosine of u is the negative sine of u, but u is 2y, right, times the derivative of u, which is going to be 2 There's a 1 here, multiplies here, then you lose the y. And this is dy dx, and the derivative of 1 is 0. So that's what it said it equals 0. So this is what we got to start with. So even though I haven't multiplied this out yet, I'm going to go ahead and get rid of this and get it out of the way so it doesn't confuse me. And I'm going to go ahead and multiply 2 times 2. And you got a negative sign there, so 2 times 2 times negative 1 is negative 4. Sine of the angle of 2y dy dx equals, like I said, I'm subtracting this to get it out of the way. So I got that. So now I'm going to divide both sides by this negative 4 sine 2y. So dy dx equals negative cosine of x over. Now we got another negative here. So we're going to make that positive because the 2 negatives will cancel out. And this becomes sine of 2y as an angle. And the 4 over here has to go with the side as well. So that'll be the denominator. There you have your derivative. It looks like it could be an issue, but you got to, watch the little things like I almost forgot before there. Thank goodness I got my notes right there. Kidneys. All right. Number 15, last one we're going to do here. So we got y equals the sine of xy. All right, so they're getting a little snotty here, a little nasty, but we can handle it just fine. Again, we think of this as y equals the sine of u, and u is equal to xy. All right, so we take the derivative of the sine of u, and that is the cosine of u. So that becomes cosine of xy. Now we come over here, and again, we've got the power rule here. We find the derivative of this. So this becomes x times the derivative of y with respect to x, plus, because they're multiplying, y times the derivative of x, which is 1. So when we bring this over here with that, this is going to be times x dy dx plus y. So that whole thing is multiplying this thing right here. Okay? So when we do that, this is going to give us y prime for that, y prime because of that, is equal to, and then now we're going to play a little, not trickery, but remind ourselves that dy dx is the same as y prime, or you could have rewritten this as dy dx. It didn't really make any difference, but this gives us the cosine of xy times xy prime plus y. Right? So that means I have to distribute this. Well, actually, yeah, I have to distribute this across over here because I got this issue here, and we'll come back to this because we've got to combine what we've got for these two right here. So I'll leave this as y prime here for now, and I'll distribute this across both these. So this is the cosine xy times xy prime plus cosine xy times y. Now I'm going to rewrite this so the xy prime are in front. And then I'm going to bring it over here to get the y primes on one side and the non-y primes the other. So let's rewrite this, get this a little more palatable, shall we say, if that's possible. So this becomes xy prime times the cosine of xy plus cosine Well, let's put the y in front of that. Let's be consistent here. So y times the cosine of xy. And that equals y prime. Now I need to bring this over here, so I have to subtract this entire term from both sides. And when I do that, I get y prime minus xy prime cosine xy equals y cosine xy. Notice like a prime, I'm going to make sure you understand that's a parenthesis there. Actually two parentheses, but I ran out of room because that's how I roll, baby. Now I'm going to factor out a y prime over here. And when I do that, that leaves me one right here. Again, you got to be careful of that. Here, let me put a red warning sign right there. Be careful of that when you factor out. That doesn't leave you 0, that leaves you 1, because we're doing factors, not addition. So 1 minus, take the y prime out of this, x cosine xy equals y cosine xy. And now, you get y prime by itself, I'm going to divide by this thing right here. So I get y prime equals y cosine xy over 1 minus x cosine xy. And that, ladies and gentlemen, is the derivative that we were trying to get implicitly. Your assignment. Page 146, problems 2 through 16E. Go slowly through it. Make sure you're able to separate things in your mind as you write it down on your paper. Okay? You try to skip steps like I kind of did a couple times there. Do it when you're comfortable doing it. Don't do it until you're 100% sure you know what's going on. All right? There's your practice problems. Good luck.